Okay, let's pull back the curtain on one of the biggest secrets in AI. We're talking about the secret recipe for making AI systems you can actually count on. And here's a hint, it's not just about fancy algorithms. It's all about creating something called the golden seed.
So, why do some AIs just fail? I mean, we've all seen the headlines, right? A self driving car gets totally confused, or a chatbot says something completely bizarre and unhelpful. We tend to blame the AI model itself. But what if that's not the real story? What if the problem is much, much deeper? What if the AI was basically set up to fail from day one? Because here's the simple, honest to goodness truth about AI it all starts with the ingredients. You just can't build a masterpiece on a flawed foundation. It's kind of like cooking. The quality of what you put in is always going to determine the quality of what you get out. You know, there's this classic saying in computer science garbage in, garbage out, or GIGO. It's simple. If you feed a system junk, you're going to get junk back. Now, in the age of AI, where these systems learn directly from data, this isn't just a cute phrase. It's literally everything. A super powerful AI that's trained on garbage data? Well, that's just a really, really fast way to make even more garbage. And look, the stakes here could not be higher. We are not talking about a chatbot getting a movie recommendation wrong. Think about self-driving cars or AI helping doctors with a diagnosis or systems that detect financial fraud. In these areas, a mistake caused by bad data isn't just some little error, it can be an absolute catastrophe. So trustworthy AI needs trustworthy data, period. So how do we fix this? How do we get that perfectly clean, high-quality data we need? Well, there's a solution. It's a systematic four-step recipe. And I want you to think about it like baking. We're going to start with this big bag of messy, raw flour, and step by step, we're going to refine it into a perfect golden seed.
And this is where almost every AI project starts. You're just drowning in data. You have a massive quantity of it, but the quality, it's way, way down here. It's full of noise, mistakes, and just plain irrelevant junk. And that's our big challenge.
So here's our roadmap. We're going to pour all that data through a four-stage funnel. And with each stage, we're going to filter out more and more of the impurities. The key idea here is that we're sacrificing sheer quantity to get a massive boost in quality. Let's walk through it.
All right, let's use an example. Imagine we want to build an AI that's amazing at recognizing cats. We start by grabbing a huge pile of 100,000 photos of animals off the internet. This is our raw material, and believe me, it is a complete mess.
I mean, sure, there are cats in there, but there are also dogs, blurry photos, pictures that are labeled completely wrong, the whole shebang. In our baking analogy, this is like buying a giant sack of flour that's just full of rocks, dirt, and all sorts of other stuff you definitely do not want in your cake.
Okay, so after our first pass of filtering, we've already cut that number way down to 40,000 images. See what's happening? We're immediately trading a bunch of quantity for a real jump in quality.
So how'd we do that? We created what's called the core dataset. We use a few different automated algorithms, and we basically ask them to group similar photos together. We only keep the photos that all the algorithms agree on. This gets rid of the most obvious junk. It's just like sifting our flour through a couple of different sieves to get rid of all the big rocks and pebbles.
Next, we get even stricter. We cut our dataset in half again, all the way down to 20,000 photos. Yep, the pile is getting smaller, but it's getting so much smarter. Now, this step is really clever. We take those 20,000 images and show them to a bunch of different pre-existing AI models. We're asking, hey, which of these photos do you all recognize as a cat with super high confidence? We only keep the ones that pass that test. It's like we're test baking our dough in a bunch of different ovens to see which batch comes out perfectly every single time. And finally, after all of that filtering, all of that sifting, we arrive here. We have 8,000 absolutely pristine photos. This is it. This is our golden seed, the best of the best. But wait, there's one last super important step. We take these AI-vetted images and show them to actual human experts, veterinarians, animal specialists, and they give the final thumbs up. This is the expert chef tasting the final loaf of bread and saying, yep, that's flawless. Now, what's so cool about this whole process is that we don't just end up with one perfect data set. We don't throw everything else away. Instead, we've organized our data. We now have a whole pantry of ingredients, and each one has a clear quality grade. So we end up with this really clear system. You've got grade D, that's our raw, messy flour. Grade C is the stuff that's been sifted. It's pretty good for some extra training. Grade B is that high-quality AI-vetted data. That's going to be our main training stuff. And right at the top, grade A, our golden seed. That's the absolute best, and we use it to plant the initial seed of knowledge and to test the final AI.
So what? Why go through all this trouble just to grade our data? Because it unlocks a much, much smarter way to actually train the AI. It lets us use a quality-first approach. And here's the recipe for success. You don't just dump all the data in at once. No way. First, you train your brand new AI only on that small, perfect, grade A golden seed dataset. This builds a rock-solid foundation. Then, once it's learned the basics perfectly, you gradually add the grade B data to make it better. And finally, you carefully mix in the grade C data to help it understand more variety in the real world.
The whole idea, the whole philosophy here is to teach the AI the right way to do things from the very beginning. The model learns the correct patterns from the start, because it's using the absolute truth of that golden data as its guide. If it starts with perfection, it won't learn bad habits that it has to unlearn later.
So let's zoom out for a second. Why does all of this matter so much? Why is this process so powerful? Because it is the very foundation we need to build AI that we can actually, genuinely trust.
Just look at this. It is the complete opposite of the chart we started with, right? We have purposefully sacrificed a huge amount of raw quantity to get nearly perfect 100% quality. That is the trade-off, and it's that trade-off that leads to AI systems that are reliable, predictable, and safe.
So, at the end of the day, here's what's so important. Creating a golden seed turns data from just a chaotic mess into a real strategic asset. It makes quality something you can actually measure and manage, not just some vague idea. And for the critical AI that's becoming a bigger and bigger part of our lives, this isn't just a nice idea. It is absolutely essential.
And that really leaves us with one final thought. As AI gets more and more powerful, the most important question we can ask isn't how much data do we have? It's how good is it? So are we taking the time to carefully build the foundation for our future, or are we just hoping for the best by building on a mix of golden seeds and raw, unfiltered flour? The answer to that question is going to define the world we create.